you want to find out the probability of A union B whole dash, then you have to subtract probability of A union B by 1. To find the two events are independent, that is P of E intersection F must be equal to P of E into P of F. If this condition satisfies, then we can say that E and F are independent events. Probability of A complement and probability of A is equal to 1. So if 1 is necessary, then you need to subtract the other by 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to take up the problems related to the chapter probability. So let's look at the problems or the kind of problems you might expect for your examination. So in this chapter, today we are going to discuss on 2-mark questions and 3-mark questions. So that means, let's see the distribution of marks in this chapter. So from the type of questions you can observe here, you will get 1 2-mark question and 1 3-mark question from this chapter. So in total, you can expect 5 marks from this chapter. So let's see the type of 2-mark questions and the type of 3-mark questions and solve it. The probability of occurrence of two events A and B are 1 by 4, 1 by 2 respectively. The probability of their simultaneous occurrence is 7 by 50. What is the probability neither A nor B occurs? So that means here none of the events should occur. So it is clearly, you can see the probability of an event A is given. So that is P of A is given. That is 1 by 4. Probability of an event B is given. So that is 1 by 2. Simultaneous occur is given. That is A intersection B is given. So that is equal to 7 by 50. Now, we are supposed to find the occurrence where A and B both do not occur. So that means we need to take the complement of this. We are supposed to find probability of A union B whole dash. How we are going to find it? If you want to find out the probability of A union B whole dash, then you have to subtract probability of A union B by 1. So let's find out this now. Now I need to find out the complement of A union B. So this is what I need to find out. So this is how I'll get 1 minus probability of A union B. Because we know that A complement, or we can say probability of A complement and probability of A is equal to 1. So if 1 is necessary, then you need to subtract the other by 1. So now we know the formula for this, that it is equal to 1 minus probability of A plus probability of B minus probability of A intersection B. So from the data, we have probability of A as 1 by 4, probability of B as 1 by 2 and A intersection B as 7 by 50. So on solving this, here 4 to 50 is the LCM here. So we will get 100 as the LCM. So here we will get 25, here we will get 50 and here we will get 52s are 2 7s are 14. So which is 1 minus 61 by 100. Again on solving this, we'll get 100 minus 61 by 100. So that is equal to 39 divided by 100. So this is the probability of the occurrence of neither A nor B. Next, what is the probability that there will be 53 Mondays in a randomly selected leap year? When I say leap year, we have 366 days. So in 366 days, 364 days will give you the complete weeks. That is, which is equal to 52 weeks. So 364 will give you the 52 complete weeks, means the remaining days are only 2 days here. And out of the 2 days, what are the chances those 2 days are? Means they can become Sunday, Monday, or they can become like this: Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday and Sunday. So these are the possibilities of the remaining 2 days that they can become one of the pairs here. So now here, how many chances we have here? We have total 7 chances of the 2 days, and out of the 7 chances, the probability that it has to be Monday is only in the 2 cases, that is Sunday or Monday, on Monday or Tuesday. So that means out of 52 weeks, we will get 52 Mondays, and we need total 53 Mondays, and that 53 Mondays, either it will be in the form of Sunday, Monday or Monday, Tuesday. So therefore here, probability of getting 53 Mondays is 2 by 7. So this is about leap year. If they have given 365 days, then only 1 day will be remaining out of 360 days. So therefore, the probability of getting one more Monday will be 1 by 7, because we have only 1 day left. And here we have 2 days, and therefore we can get days in the form of ordered pairs. So therefore, we have 2 chances. Either it may be in the first day or it may be in the second day. That's why we will get the probability as 2 by 7. Next, one ticket is drawn at random from a bag containing 20 tickets, numbered from 1 to 20. Okay. Numbered from 1 to 20. Find the probability that it is a multiple of 2 or 5. So let's see here. Total is 20. So we have 20 tickets, and let me consider set A, where we will write the tickets which are multiples of 2. That means we have 2, 4, 6 until 20. So how many we have here? So that is how many tickets we have. Cardinality of A is 10. So therefore, the probability of A will be 10 divided by 20, because out of 20 tickets, we have only 10 tickets which are multiples of 2. So therefore, probability of A is 1 by 2. Next, we will check the probability of 5 here. So let me consider it as set B. So that is 5, 10, 15, 20. So we have only 4 tickets. So that means the cardinality of B is here 4. Cardinality is nothing but the number of elements inside the set. So therefore here the probability of B will be 4 by 20. So which you will get it as 5. So which is equal to 1 by 5. Now we need to find out the probability of 2 or 5. That is probability of A or B, which is nothing but your union. So probability of A or B. So you can clearly see here, we have 2 elements which are common in both the sets. That is A intersection B. So when I say multiple of 2, 10 is also multiple of 2, 10 is also multiple of 5, and 20 is also multiple of 2, and 20 is also multiple of 5. So we have 2 elements in common in both the sets. Therefore, probability of A intersection B will be 2 divided by 20. Hence, you will get the value as 1 by 10. Since we need to find out probability of A union B, this can be found using probability of A, probability of B minus probability of A intersection B. We need to find the probability of each individual values here. So here we'll get 1 by 2, 1 by 5 minus 1 by 10. So if you take this, you will get this as 7 by 10 minus 1 by 10, which is equal to 6 by 10. So you can 5 ones are 5, 2 ones are 2, 5 plus 2 is 7 and 5 twos are 10. 6 by 10, when you cancel this with 2, so you will get probability of A or B as 3 by 5. So this is the value of the probability, which is a multiple of 2 or 5. Next. A bag contains 5 red, 7 yellow and 8 green marbles. 3 marbles are drawn randomly from the bag. What is the probability that all the 3 are red here? So, let's check total number of marbles here, that is 5 plus 7 plus 8. So, that is we have 20 marbles inside the bag. And I am choosing only 3 marbles. So, how many red marbles we have? We have 5 red marbles. Out of 5 red marbles, all the 3 must be red. So, therefore, choosing or number of selection of choosing red ball will be in the form of 5C3. And when it comes to the probability, it is always the number of selection or the number of favorable divided by total number of outcomes. And total number of outcomes will be equal to 20C3, because out of 20 marbles, we are selecting only 3 marbles. And my question is that all must be red. So, therefore, probability of the given event, or that is probability that 3 are red, is equal to 5C3 divided by 20C3. So, 5C3 is 5 into 4 into 3 divided by 3 into 2 into 1 whole divided by denominator is 20 into 19 into 18 divided by 3 into 2 into 1. We can cancel 3 to 1, 3 to 1 here. 5 4s are 20, 5 4s are 20. So, here we have 3 1s are 3 6 are. So, we have 1 in the denominator. 19 into 6, 114 in the denominator. So, 1 by 114 is the value of probability that all the 3 of them are red. Next, if P of A is 1 by 2, P of B is 1 by 3, P of A union B is equal to 7 by 12, find the conditional probability of B over A. So, we know that to find the conditional probability of B over A, we need probability of A intersection B, and that is divided by probability of A. So, to find probability of A intersection B, we can use the formula probability of A intersection B is equal to probability of A, probability of B minus probability of A union B. So, if you want to find out A or B, then you need to subtract A and B. If you want to find out A and B, then you need to subtract A or B. So, therefore, here we will get 1 by 2 plus 1 by 3 minus 7 by 12. So, now if you take the LCM, you will get 12 as the LCM. So, 2 6 are 12, 3 4s are 12, minus 12 1s are 12. So, 6 plus 4 minus 7, whose value is equal to 3 divided by 12. So, which can be cancelled, 3 1s are 3 4s are. So, 1 by 4 is the probability value. Now, here if you substitute, you will get 1 divided by 4 divided by 1 divided by 2. 2 1s are 2, 2s are. So, therefore, the value is 1 by 2. That is probability of B over A is 1 by 2. Next, a box contains 8 red, 6 green and 10 pink marbles. One marble is drawn randomly from the box. What is the probability that the marble drawn is either red or green? So, now here let's see the total number of marbles here. So, that is we have 8 plus 6 plus 10. So, total we have 24 marbles. And one marble is drawn here. So, therefore, we need to choose only one marble, and that marble should be either red or green. So, how many red we have? We have 8 red. How many green we have? We have 6 green. So, 8 plus 6, 14 marbles we can select so that it will be either red or green. So, therefore, the probability value will be equal to 14 divided by 24. So, 2 7s are 2 12s are. So, 7 by 12 is the value of the given probability. Next, let's look at 3 marks questions here. So, maximum 3 mark questions will contain a question in the form of 3 sub questions. A 1 mark simple probability values you need to find out by observing the questions. Now, here 3 fair coins are tossed simultaneously, find the probability of getting one head. So, whenever 3 fair coins are tossed, our sample space will be in the form of H, 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 T, H, T, H, T, H, H, T, T, H, T, H, T, H, T, 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 T. So, T represents the tail and H represents your head. So, my first question is getting one head. So, how many elements have one head here? So, you can clearly see you have 3 events which contain one head. So, let me choose the probability of an event A, that is getting one head. So, that is 3 divided by 8. Second one, getting at most to 2 heads. At most is nothing but less than or equal to 2. When I say less than or equal to 2, you can get the values of no head, one head or 2 heads. So that means except the first one, you can select all the outcomes here because the first outcomes contains 3 heads, which is maximum, and here they are saying that at most to 2 heads, that is 2 heads is the maximum you can take. So therefore we can take 2 heads, 1 head and the outcome which contains no head. So therefore the probability of an event B, where B is nothing but getting at most 2 heads, is 7 by 8. Next, C says getting at least 2 head. At least means greater than or equal to 2. That is the event containing 2 heads as well as the event containing more than 2 heads. That is the outcome containing 2 heads or the outcomes containing more than 2 heads. So what are the outcomes now? We can see the first 4 outcomes have 2 heads there. So therefore, probability of an event C, where C is getting at least 2 heads, is 4 by 8, whose value is 1 by 2. So just observing the question, you need to find the probability of a given values here. Next, a card is drawn from a well-shuffled pack of 52 cards. Find the probability that a card is blackjack, card is diamond, card is red. So, drawing card is, total number of cards is 52 cards. Let me look at the first question. The first question says blackjack. So jack is a face card. So you have 4 jack, and out of 4 jacks you have 2 red jacks and 2 black jacks. So when I say card is a blackjack, we have 2 blackjacks, which one is spade and one is club. So therefore the probability of A is 2 out of 52. Because out of 52 cards we have a jack card which is black, only 2. So therefore it is 2 divided by 52. So therefore when you cancel it, this will be equal to 1 divided by 26. Next question we have, card is a diamond. How many diamond cards we have? We have 13 diamonds. So therefore probability of getting diamond is 13 by 52 and the value is 1 by 4. Next, card is red. How many red cards we have? We have diamond as well as heart as red. 13 diamonds and 13 hearts is 26 red cards. So therefore, probability of getting red cards is 26 divided by 52. So therefore, the value is 1 by 2. Next question. The probability that India win a cricket test against Australia is 1 by 3. If India and Australia play 3 tests, what is the probability India loses all the 3 tests, India wins all the 3 tests, and India wins at least 1 test? So now let us look the possibility here. The probability that India win the test match against Australia is 1 by 3. That is, the probability of winning is 1 by 3. Then what is the probability of losing? It has to be 1 minus 1 by 3. That is equal to 2 by 3. So my first question given here is India loses all the 3 tests. So that means probability of losing all the 3 times. So it is P of L, P of L, P of L. So that means 2 by 3 into 2 by 3 into 2 by 3, which is equal to 8 divided by 27. Next question we have probability that India will win all the 3 matches. So probability of winning in all the 3 matches, P of W, P of W, P of W. So that is, we have 1 by 3 into 1 by 3 into 1 by 3, whose value is 1 by 27. Next, they say India will win at least 1 test match. So when I say at least 1 test match, then the probability or the possibility of getting probability of, so first match they may win, the next 2 matches they may lose. So next, so it may be lose, win, lose. So, or it may be lose, lose, win. Or they might win. Since I say at least, they can even win 2 matches and lose 1 match. So therefore, it may be win, win, lose, or win, lose, win, or lose, win, win. And the last one means they might win all the 3 matches. So you can clearly see here probability of winning, losing 2 times, and losing 2 times, winning, losing 2 times, winning. So you can take it as 3 times probability of winning, lose, lose. Next, here also you can see in all the 3 probability, India is winning 2 times and losing 1 time. So therefore it is nothing but 3 times probability of winning and losing. 3 times. And the last one is only once. So therefore, here you can see 3 times the probability of winning, P of L, P of L, plus 3 times probability of winning, probability of winning, probability of losing, plus probability of winning, winning, winning. So that is, we have already got this P of W, W, W. So let's see now, 3 times into winning is 1 by 3, 2 by 3, 2 by 3, plus 3 times 1 by 3, 1 by 3, 2 by 3. So this we have already found, that is 1 by 27. So now here 3, 3 get cancels, 3, 3 get cancels. So you can clearly say 2 2s are 4, 3 3s are 9. So the value is 4 by 9. Next we have 2 1s are 2, 3 3s are 9. So 2 by 9 plus 1 by 27. On solving this, so we will get the value as 19 divided by 27. So this is the probability of India winning at least 1 match. Next, a die is thrown. If E is the event, the number appearing is a multiple of 3, and F be the event, the number appearing is even, then find whether E and F are independent. To find the 2 events are independent, that is P of E intersection F must be equal to P of E into P of F. If this condition satisfies, then we can say that E and F are independent events. Now, let's find the probability of E. So when you throw a die, a number which is a multiple of 3 is only 3 and 6 out of 6 outcomes. So therefore the probability will be 2 by 6. And when you throw a die, the number appearing is even is only the 3 outcomes. They are 2, 4, 6. So therefore the probability of event F is 3 out of 6 outcomes. And when you throw a die which is both multiple of 3 as well as even is only 6. That is probability of E intersection F is only 1 by 6. Now let's multiply probability of E into probability of F. So that is 2 by 6 into 3 by 6. So which is 6 by 6 cancels 1. And clearly you can see probability of E intersection F value is 1 by 6. So P of E intersection F is not equal to P of E into P of F. So therefore clearly we can say that E and F are not independent, or we can say they are dependent events. Next, a bag contains 10 gold, 8 silver coins. 2 successive drawing of 4 coins are made. Find the probability that the first drawing will get 4 gold and the second 4 silver coins if coins are replaced before the second trial, coins are not replaced before the second trial. So this is with replacement and this is without replacement. So now a bag contains, so consider a bag here. So we have 10 gold and 8 silver coins. So we need to select 2 successive drawing of 4 coins. That means every time we need to choose 4 coins, even in the first trial as well as the second trial. So we need to find that the probability of the first drawing is 4 gold and the second coin is 4 silver. Now see here. So let me check probability of getting 4 gold in first draw. 4 gold in first draw. So how many golds we have? We have 10 golds, but I need to choose only 4 coins. So therefore it is 10 C4 out of total we have 18. So therefore 18 C4. Next, probability of getting 4 silver in second draw. When I say in second draw, so the condition is given that coins are replaced before the second trial. That means 4 gold coins which I have taken out, I have put it inside the bag again. So therefore again there are 18 coins. Out of that we need to choose only 4 coins and that 4 coins has to be silver. So therefore it is 8C4. So therefore probability of 4 gold and 4 silver coins in both the trials is equal to 10C4 divided by 18C4 into 8C4 divided by 18C4. Now look at the second question. Coins are not replaced. So let's check the condition here. We have 10 golds and 8 silver coins. So let's take 4 gold coins in first draw. So in the first draw we have 18 coins inside the bag and I need to choose 4 coins and that 4 coins has to be gold. Now I have taken 4 gold coins outside the bag. Now the probability of getting 4 silver coins in the second draw. So now since I have taken the 4 coins outside the bag, I have left with only 14 coins inside the bag. So therefore out of 14 coins, I need to choose 4 coins and all that 4 coins has to be silver. So therefore it is 8C4. So therefore here in the second case, the probability of getting 4 gold and 4 silver will be 10C4 divided by 18C4 into 8C4 divided by 14C4. So this is the possibility we can get. Next. Now, next question. A couple appears in an interview for 2 vacancies in the same post. The probability of husband getting selected is 1/7 and the probability of wife getting selected is 1/5. What is the probability that both of them will be selected? One of them will be selected, none of them will be selected. So when I say none of them will be selected, I need the complement of the selection. So now let's take the probability of wife getting selected and probability of husband getting selected. The value of it is given. So that is the probability of husband is given as 1/7, wife is given as 1/5. What is the probability that husband is not getting selected? That is 1 minus 1/7, which is 6/7. What is the probability that the wife is not getting selected? That is 1 minus 1/5. That is equal to 4/5. And here my first question says probability that both are getting selected. That is both are getting selected means it is P of A into P of B. So that is 1/7 into 1/5, which is equal to 1/35. Second question is any one of them is selected. That is if husband gets selected, wife is not selected, or if wife gets selected, then husband is not selected. So that means we can take probability of A, probability of B dash plus probability of B, probability of A dash. So that is 1 by 7 into 4 by 5 plus 1 by 5 into 6 by 7. So on solving this, we'll get 4 by 35 here plus 6 by 35. So here, that is probability of A B dash or B A dash will be equal to, when you take the sum, you will get the value as 10 by 35. On solving this, you will get 2 by 7. The last one is probability is none of them are selected. That is, not even wife, not even husband is selected to the job. So that means we are finding the complement probability of A dash into probability of B dash. So probability of A dash is 6 by 7 and probability of B dash is 4 by 5. So that is 24 divided by 35. So these are all the few questions we have solved. So you have seen that you can get what type of questions for 2 marks and 3 marks question. So we will meet you in the next session with the next chapter. Until then, keep watching, keep learning, keep exploring. Thank you.